Okay, continuing in our series of inverse trig derivatives. I said that we would continue down our list. We've just done tangent. Here we are doing cosecant. So I've set it up in the same way: cosecant inverse of x equals y, or arc cosecant of x equals y. We start, as always, by taking the cosecant of both sides. So we have x is equal to the cosecant of y. Now we're going to take the derivative of both sides, d dx. And I'm a broken record, but we are keeping in mind not only trig derivatives. Of course, we'll need a trig derivative to do the derivative of cosecant, but also the chain rule and implicit differentiation. So we'll take the derivative of x, which is just 1, the derivative of cosecant. I've got 1 cosecant, I need 2 and a tangent. Coming back to a rule that I talked about in an earlier video for how to memorize these. So we need 2 secants and 1 tangent. Here we've got 1 secant or cosecant, so we'll need another one, cosecant of y, and a cotangent. Since this trig function starts with a c, the derivative is negative. That is a rule that I talked about in another video that can help you memorize these. Of course, I've got the derivatives here. Okay, but we're not done. That's the derivative of cosecant of y, but we need to multiply by the derivative of y, which is dy dx. Okay. Like in other videos, we decided that we would pick an angle to be y and use the property that the cosecant of this angle y is equal to x. Okay, now if you're forgetting cosecant's relationship to a triangle, we can remember that it's just the inverse of sine. So sine is opposites. If there's any room here, there's sine is opposites over hypotenuse, and since cosecant is the reciprocal of that, it's just the hypotenuse over the opposite side. Okay, I think we went off the page there. So cosecant is h over o. Okay. Cosecant of y is equal to x. Whatever's in the numerator is going to be x, so in this case the hypotenuse, and the opposite side is going to be 1. Like in other videos, we're going to find this adjacent side by doing the Pythagorean theorem. We have a squared plus 1 squared equals x squared, or a squared equals x squared minus 1, a equals the square root x squared minus 1. Great. So this is this side, square root x squared minus 1. And we'll go back to our equation. I actually think that maybe we want to isolate dy dx first, because I'm a little bit less comfortable with cosecant and cotangent than I am with their reciprocals. So we'd be doing 1 divided by negative cosecant y cotangent y. 1 divided by cosecant is just its reciprocal, so negative sine of y. And cotangent, we'd use the reciprocal property as well. This is tangent of y. Okay, so our derivative is negative sine y, tangent y. And if we look at y, the sine would be 1 over x. So dy dx is equal to negative, first of all, we'll just do sine, negative 1 over x. And tangent of y is the opposite, 1 over the square root of x squared minus 1. 1 over the square root of x squared minus 1. Okay, and I'm just going to erase this so we can multiply this out and formalize our answer. we have the derivative of cosecant inverse of x is -1 over x square root x squared minus 1. All right, we'll check in with the derivative of secant.